Hello, welcome to the Chesapeake Chapter dinner meeting for the month of May. I'm Gundars Oswald, the program director. And today we have the author of this book, Mark Gertschwitz, in Defining Enterprise Architecture. And I think the thing is that I've done enterprise architecture for years, and one of the things I realized is the context of the architecture. Who's the customer? Who are you doing it for? And what are you doing? And I think this is something that he's covered in very well in his book and his presentation. So let's see Mark go to town with it.
Welcome to a systems view of whole enterprise architecture. My name's Mark Gewurz. I'm an enterprise architect who applies systems engineering principles, practices, and methods. I specialize in the integration of business processes and resources, advanced methodologies, and integrated team concepts. Prior to management consulting, I had a long career at Lockheed Martin, beginning at GE Aerospace. My experience spans all size businesses, from startups to mega corporations, performing work for government, commercial, not-for-profit, system and service providers over a wide range of domains. I have an extensive background in cross-functional topics. I've worked with dozens of companies participating in supplier selections and qualifications, business audits, consolidations of mergers and acquisitions, the development of new enterprises and other EA programs, projects, initiatives, and business transformations. The presentation will begin with an overview of the problem and solution, then defines an enterprise in context to the practice of EA, followed by defining basic and fundamental functionalities, to arrive at a view of an enterprise in the context of being a system, concluding with time for questions and answers. Getting started. EA frameworks were organically developed around business needs for IT. Except for Zachman, all frameworks begin in practitioner-specific implementations. Top-down approaches without first addressing the architecture of the enterprise. Traditionally, an enterprise architecture is considered to be a business and an IT architecture. There is no framework defining the enterprise as a whole, nor integration of the parts which form this undefined whole. Traditionally, the practice of EA has been used to architect IT for business needs, effectively equating the terms business and enterprise and subordinating IT. For example, BizBock is an example of an implementation of EA serving the needs of the business architect. And likewise, TOGAF serves the IT architect. Traditionally, EA begins with determining business capabilities, needed gaps, and strategies, handed down to and ending with IT capabilities being deployed. Where the other architects fit in EA is not clear. Traditionally, the business architecture is basically everything that is not IT, except for process and information, which gets complex as they are partially present in both architectures. Mission capabilities and technologies are not, mission capabilities and technologies other than IT are not clearly covered. Nothing establishes the relationships between the frameworks. Each framework contains topics which overlap frameworks without breakdown by skill set, effectively creating a super architect role, with the skill sets and knowledge of all architectural domains and the ability to accomplish anything and everything. The term framework implies a structuring of the elements of the framework, yet every framework is structured differently and lacks ontological structure. Frameworks do not consider the state of what should be along the path to the desired to be. Frameworks do very little to help a team of various architects work together to do their jobs. Frameworks do not address who does what in getting specific jobs accomplished. Complexity is compounded by the lack of EA-specific basic terminology. Industry standards exist, but not in the context of people and technology systems working together as socio-technical systems. Terms are used freely out of context, confusing the understanding of the concepts being described. For example, the term organization. If I state the organization has capabilities, am I referring to a department of people reporting to a manager or the way tools and materials are arranged around work activities? Using terms independent of whether they are in the context of structural definition or functional application causes more confusion on top of confusion. For example, the term process. If I say the enterprise has processes, do I mean procedures, practices, and instructions, or do I mean people and machines performing tasks? Complexity is further compounded by the overriding use of organization-specific terms and needs for industry products and services which support the practice of EA, resulting in an industrialized environment where the use of marketing terminology and buzzwords abound, where anyone can be titled anything without relation to specific knowledge, experience, skills, abilities, or responsibilities, where software tools define the practice and mislead the way in knowing how to do it, where certification precedes knowledge of actually knowing how to apply skills and abilities, all leading to miscommunication and misunderstandings of the who's, what's, and when's of actually practicing EA. Addressing the problem begins with the architecting of the enterprise, where the enterprise is considered as a system in the classical meaning, and step by step extrapolate the system through increasing specifics of purpose and usage to arrive at a socio-technical system. To be a system, the system must have a boundary, which establishes its internal and external environments. Things internal to the system being of the system, things outside the system being things which interact with the system. All systems are relevant by their existence, defined by their structure, which functions to serve the purpose for their existence. All systems are composed of a whole, which has parts. Each part has relationships with other parts, relationships with the whole. All systems have command and control functionality, which communicates with the parts of the system to enable and assure the system and parts behave as desired. All systems have inputs of matter, energy, and/or information to the system, which are transformed by the parts of the system to produce outputs of matter, energy, and/or information from the system, for the ultimate purpose of sustaining the system for the life of the system, both internally and within the environment surrounding the system. Next, the system is placed into the context of being a technology system in its external environment, where the application of the technology's related functionality in serving its purpose is intended to be a value-adding, sustainable situation over the life of the system. Inputs of value to the system are transformed by the parts of the system into outputs of higher value, serving the value-adding function-related purpose of the technology, exchanging lower value for higher value to the external environment, but also in so doing, maintaining or increasing the value of its internal environment. In other words, in doing what the system does in the external environment, the system structure has to be able to internally survive its functioning to serve its purpose. Next, the technology system is placed into the more specific context of being a management information system, with a management-based information-related function serving a management-based information-related purpose, along with an IT services system with an IT-based service-related function serving an IT-based service-related purpose, interconnected with inputs to the management information system transformed into outputs from the IT services system. Each system operating within a separate internal environment. Each system working within a common external environment. Each system serving its purpose independent of a purpose for connecting the two systems together. The problem with this situation is the ability of each system to communicate with and understand and survive the other system and serve its intended purpose cannot be fully determined until it's first determined what higher order purpose the combination of the two systems is intended to accomplish. By next placing the two technology systems into the context of a managed backup and recovery functionality, a system of systems, a SOS, is formed with lower order systems of specific purpose placed within a specific higher order system, with a specific higher order purpose beyond the purposes for the lower order systems. Two systems of different purposes operating together for a common purpose. For different systems of different purposes to communicate with and understand each other, the specifics of the interconnections and interfaces between the systems must be systematically addressed in order for the systems to interconnect and work as desired, with value to all the systems and their environments. Various application and domain-specific interfaces and methods of interconnection are used as appropriate. Interconnections are differentiated by their form, their function, and the purpose they serve. And to address the characteristics, levels, and physical ability of the interconnections to conduct communications. The point to be made is the expected behavior of a technology system, or SOS, can be predetermined through its design. But that is not the case once people are added to the equation, as people, by nature, are adaptive. And their adaptive ways tend to have unintended and unforeseen influences on what are otherwise considered to be deterministic means, probably resulting in an unintended or unforeseen outcome. So all bets on in determining the behavior of a system when placed into the context of an operating business capability. For example, a capability to develop and operate a technology system, a business system whose goal is a business functionality, where the technology system being developed and operated interacts with a rapidly changing, complex mixture of resources, such as machines, tools, and equipment, information, materials, and other things needed, goods, services, and associated work products produced and used, a workforce of executive managers and individual contributors, and their devices, including system managers and architects who may or may not be adding value in this situation, as it is complex and not easily nor reliably determined. Next, we place the business system into the specific context of backup and recovery, where there is a business system for managing backup and recovery, and a business system for backup and recovery operations. To make the situation more complex, unlike technical systems with dedicated resources within each system, with business systems, there is most often sharing of the resources. In this example, the management information system, and potentially every other resource, including the human resources. The point to be made is each business system has its own goals. These goals are placed upon the business system by placing goals upon the workforce. These goals influence the workforce to focus on meeting their individual goals. Without a common goal, just as with technology systems and their function-related purposes, the compatibility of two business systems properly working together cannot be determined. But by placing the two systems into the higher order purpose of backup and recovery services, and what the purpose of and needs for these services are, the individual business systems can be transformed into a business system of business systems, with IT managers and architects individually working together, sharing resources as needed for the purpose of meeting their common goal, providing backup and recovery services. Next, we place business systems into the specific context of desktop applications, where there's a business system for desktop applications management and a business system for desktop application operations. And similar to backup and recovery, we can place these two business systems into a higher order IT functionality related purpose of desktop application services, with IT managers and architects. And similarly, we can combine backup and recovery services with desktop application services into the higher order business-related purpose of desktop computing services, a SOS squared, with business managers and architects. And similarly, we can combine desktop computing services with database services into the higher order company-related purpose of web services, a SOS cubed, reaching a configuration of business systems where the people who develop and operate the technology systems which support them are beginning to be hidden in the details of web services. And then combine web services and e-commerce services into the higher order corporate-related purpose of web and e-commerce services. The point to be made is the enterprise does not need to be an internet giant for the business systems to quickly get complex, as business systems are complex, even in the most simple of situations. such as the case of the most basic and fundamental business sauce, just two different business systems, functioning with different purposes, working together for a common purpose. In today's world of a highly interconnected mix of people and technology, in a rapidly changing, cost-reducing, and ability-demanding market environment, when it comes to developing and operating technology systems for cross-functional business applications, controlling the whole enterprise and all its socio-technical parts to achieve acceptable outcomes for the customer and the enterprise as a whole is not easy. Because the view that everyone sees their work as they do their jobs is a bottoms-up, inside-looking outward view, where the people and goals related to the business systems developing and operating technology systems and services are 1 degree, 2 degrees, 3 degrees, and 4 or more degrees of separation away from the people and goals related to the business systems, the technology systems, and services support. In practice, we recognize the separation of people by goals as a functional silo when it comes to working and getting the job accomplished. Each collection of people focused on accomplishing their own goals. But in the design of a business-wide capability in today's world, it can be a functional silo to the 4th power. This is why the business strategist thinks the architecting of the technology system or service is down in the details of the technical weeds. And technical considerations do not deserve consideration in the development of strategies, in the architecting of the business, up in the executive office, with IT people stuck in the middle between business people and the product systems and services people. The point to be made is the development of a technology product system or service for a business-wide purpose in terms of meeting needs throughout the structure of needs is a compounding of probabilistic systems within probabilistic systems, which will most probably be problematic if the management of the probabilistic systems are not architected into the design of the systems. In other words, actions must be taken to enable and assure the elements of the socio-technical system are achievable and manageable within the desired control limits for the desired length of time, just as in the design of any technical system. Similar to technology systems, for different business systems of different goals to communicate with and understand each other, the specifics of the lines of communication between the systems must be systematically addressed in order for the systems to interface and work as desired, with value to all the business systems, to the enterprise as a whole, and to their environments. Various application and organization-specific interfaces and methods of interacting are used as appropriate. Interactions are differentiated by organization, the function they serve, and the goals they have. And the characteristics, levels, and physical ability of the interactions to conduct communications are addressed. The point to be made is communication understanding or application organization specific. Since the abilities of people working on an EA team have application and organization-specific difficulties and deficits, resultant of the complexity and complications of frameworks and terminology, the practice of EA has communication and understanding difficulties which must be solved for the practice of EA to function efficiently and effectively. The practice of EA is in need of an application, an organization neutral view of an enterprise, a top-down, outside-looking inward view, the view the system architect uses to do upfront high-level design, the view all architects need. Improving the practice of EA begins by the practice acknowledging the existence of the various skill sets, by distinguishing enterprise architecture from business and IT architecture, addressing process and information separately, and to architecturally include the development and operation of technology systems and services. By differentiating work by goals, roles, and interdependencies between all architects and all levels of management, including executives. And improving interactions through increasing teamwork, satisfying cross-functional needs, and leveraging diversity and practicing EA in order to integrate the communities of practitioners. To improve communication understanding of EA, roles and responsibilities must be differentiated by skill set, broken down by work and things needed and produced. And cross-functional dependencies be known, understood, and communicated in terms of what is used and produced, when things are needed, and their expected state at the time of need. Next, I will define an enterprise in the context of practicing EA. An enterprise can be any endeavor, but regardless of what the enterprise specifically is, an enterprise needs a mission to give it purpose and motivation. An enterprise also needs customers to give it an energy source to fuel the motivation for the enterprise to take actions to accomplish the mission. Captured in a statement of what the enterprise will do to satisfy the customers. Customers need offerings of products and systems and services. Capabilities are needed to produce offerings, and therefore, the enterprise needs people, process, information, and technology to satisfy the needs of the customer, which satisfies the needs of the enterprise. Next, I will define the basic and fundamental functionalities an enterprise needs. To further define offerings and capabilities, I will begin by defining the basic and fundamental functionalities all enterprises need. I will do this employing another method of communicating and understanding socio-technical systems called soft system concept diagrams. Part of the soft systems methodology developed by Peter Checklin, where systems of systems are represented by interconnected higher order system functions containing interconnected lower order system functions, with cross-functional interfaces at each system boundary through which all communications pass as inputs and outputs between the systems. Communication between the higher order system functions has less distance and interfaces than communication between the lower order systems. However, the interfaces between the lower order systems are more important as they are working dependencies and are of a higher need, as work always begins in lower order functions and works its way up to forming higher order system functions. As with the interconnection of technology systems, because of the various attributes of the interconnections and the length of the lines of communication, each system boundary creates a barrier, a functional silo, that is a degree of separation impacting the effectiveness and efficiencies of the interconnections and interdependencies between the system elements of different systems. In other words, the lower order a system function is, the more disconnects and independencies it has with other systems, and the less it serves the higher order needs of the other systems. To further explore this, let's place the systems into the context of being organizations of people with responsibilities for people and things. For example, the systems engineering organization with the systems development department with department goals which support the goals of the organization. And the business operations organization with the business analysis and planning department with department goals supporting organization goals. The goals of each organization keep the people and things within focused on meeting their goals and creating an independence to anything which obstructs the path to their goal. This dependently independent working interface between the lower order system functions degrades the functionality of the lines of communication, which in turn degrades the ability of each organization to accomplish its goal, which is a paradoxical situation. Without goals, organizations do not have purpose and will lose motivation. With goals, organizations are motivated to lose integration, resulting in loss of functionality. Goals, can't work with them, can't work without them. Situation's not any different, placing the systems in the context of being a capability composed of people, process, information, and technology. For example, the business capability with the goals of talent supporting the business-related goals of the business capability. And the process capability with the goals of process management supporting the process-related goals of the process capability. The goals of each capability keep the people and things within focused on meeting their goals, creating an independence to anything which obstructs their path to the goal. This dependently independent working interface between talent and process management degrades the functionality of the lines of communication, which in turn mutually degrades the ability of both to accomplish their goal. The same paradoxical situation. Without goals, capabilities do not have purpose and will lose motivation. With goals, capabilities are motivated to lose integration, which degrades functionality. That is, unless we place the capabilities in the context of being an element of a system, as in a system of systems, where each capability has a goal, which supports a common goal of higher value, improving the functionality of the lines of communication between talent and process management. And as system engineers, we readily understand this complex situation and find it easy to communicate. And it's just another inside looking outward, bottoms-up view of a capability being built up as a system. This goes into this, goes into that. So let us next take this understanding from the perspective of a systems implementation and use it to communicate an architectural perspective of an enterprise and its capabilities by using an outside-looking inward, top-down view of an enterprise being architected, as if it was a system of capability systems, developed and operated by a system of enterprise systems, beginning with an enterprise and following the flow of needs. Because enterprise architecture does not start or end with capabilities. It starts with the enterprise and it continues with the organizations of the people and things working to actually realize the needed abilities the capabilities require. Because systems can be differentiated by their structure, function, and the purpose they serve. Working capabilities can be differentiated by the multiple goals it takes to accomplish their common mission and the mission-centric functionalities they provide. As motivation turns into actions to implement the idea for an offering, a basic and fundamental enterprise functionality forms, an ability to exist, act, and behave as an enterprise. This creates the need to realize a business functionality, to form the ability to have the motivations, people, and things within activities needed to perform and achieve the intended business of the enterprise. Increases in people and things within activities drives the need to realize a process functionality, to form the ability to understand, define, and communicate the conduct of business activities. As resources within activities increase, the need to capture, comprehend, recall, and apply what is both becoming known and what is already known increases, driving the need to realize an insight functionality, to form the ability to learn, understand, communicate, and apply what the enterprise knows. Increases in needs for resources, activities, and insight drives the need to realize an IT functionality, to form the ability to provide IT products, systems, and services which support and enable the purpose for the resources, activities, and insight, and which also support and enable the mission and sustainment of the enterprise. Continued increases in functionality supports the needs of offering products and systems, forming the ability to realize a system offering functionality, an ability to develop and operate products and systems for customers. Continued increases in functionalities, including the development and operations of products and systems, supports the needs of offering services, forming the ability to realize a service offering functionality, an ability to develop and operate services for customers. Forming the ability to sustain the business cycle by forming an enterprise system functionality operating in the external working environment with customers, vendors and suppliers, industry standards and regulations, competitions, and other threats to the enterprise. Which finally brings us to looking at an enterprise as a system. Functionalities continue to increase in capability, capacity, size, and complexity, driving a need for the functionalities of the enterprise to have a systematic ability to work, realizing an interconnected and interdependent enterprise system capability, as covered in the following slides. Through time, the enterprise functionality transforms into an enterprise capability, a systematic ability to satisfy the need to control the static and dynamic behavior of the enterprise system through governance to control resources, organization to arrange, order, and assign resources, integration to bring resources together, compliance to verify resources are controlled, assurance to independently validate compliance, and enterprise management of the elements of the enterprise capability, with the capability interconnected with all other capabilities. In this way, the enterprise capability system serves as the control system of the enterprise system. Through time, the business functionality transforms into a business capability, a systematic ability to satisfy the need for conducting business. Through mission, as a means to communicate and realize the idea and vision through goals, strategies, and other motivational influences. Markets of supply and demand. A portfolio of holdings of offerings, operational and strategic capabilities. Talent, resident in a workforce with skills, abilities, knowledge, and experience. Operations of business to perform functional activities. Business management of the business capabilities, with the capability interconnected with all other capabilities. In this way, the business capability system serves as the infrastructural support system of the enterprise system. Through time, the process functionality transforms into a process capability, a systematic ability to satisfy the need for understanding, defining, and communicating work activities. Through policy, to define business requirements for performing work activities, producing work products, and utilizing resources. Procedure, to define how to perform work activities, produce work products, and utilize resources per policy. Roles, to define skill-based functional work responsibilities for work activities, work products, and resources. Workflow, to define the flow of work activities, work products, and resources. Process improvement, to define the continuous improvement and sustainment of work activities, work products, and resources. And management of the process capabilities, with the capability interconnected with all other capabilities. And in this way, the process capability system serves as the operational support system of the enterprise system. Through time, the insight functionality transforms into an insight capability, a systematic ability to learn, understand, communicate, and apply what is explicitly known through data produced and used, information produced and used, configurations of the data and information produced and used, records of data, information, and configurations, knowledge of data, information, configuration, and records, and management of the insight capabilities, with the capability interconnected with all other capabilities. And in this way, the insight capability system serves as the intelligential support system of the enterprise system. Through time, the IT functionality transforms into an IT capability, a systematic ability to satisfy the need for IT products, systems, and services through communications technologies, IT applications, IT infrastructure, information utilization, procured IT services, and management of the IT capabilities, with the capability interconnected with all other capabilities. In this way, the IT capability system serves as the computational and informational support system of the enterprise system. Through time, the system offering functionality transforms into a system offering capability, a systematic ability to satisfy the need for technology, goods, products, and systems for a customer through needs for what the system offering has to accomplish, requirements for the system offering, products needed for the system offering, a solution for the system needs, the abilities of the operating system, and management of the system offering capabilities, with the capability interconnected with all other capabilities. And in this way, the system offering capability serves as the technological support system of the enterprise system. And finally, through time, the service offering functionality transforms into a service offering capability, a systematic ability to satisfy the need for services for a customer through needs for what the service offering has to accomplish, requirements for the service offering, a catalog of the services needed for the service offering, a solution for the service needs, the abilities of the operating service, and the management of the service offering capabilities, with the capability interconnected with all other capabilities. In this way, the service offering system serves as the serviential support system of the enterprise system. And this completes the definition of the enterprise capability system. To begin to tie all this together and wrap it up, enterprise system capability is a collection of people, information, technology, and other things of value which together systematically function, that is, execute a process, to realize an ability to satisfy a customer-based need. The capability is managed to keep it within the desired control limits by enterprise system management, a collection of interconnected, shared, and time-dependent management-based resources, which together systematically function to realize an ability to control the functionality of the enterprise capability system. Management is the responsibility of the enterprise system manager role, a collection of managers systematically functioning to realize an ability for controlling the functionality of the capability. The enterprise system architect role is a collection of architects systematically functioning to realize an ability to understand and communicate enterprise system management. To architect the enterprise system capability and is responsible to describe the capability in an enterprise system architecture, a collection of architectures, systematically describing the enterprise system, which the manager uses in support of controlling the functionality of the capability. These systems are conceptual views of a systematic ability to realize offerings and capabilities, management, managers, architects, and architectures. But in practice, these concepts are physically multiple functionalities, serving different purposes for a common mission. Because capabilities are interconnected, resources are shared between capabilities, and everything changes in time, a need is driven for all systems to effectively and systematically function as one cohesive capability. Which leads to the specifics in the way the systems of the enterprise work with the operating of a capability. The managing of the capability. The architecting of the capability. The producing of architectural work products. And the producing of managerial work products. So now if we take these 5 systems, 5 enterprise systems, and we extrapolate that over all the capabilities and their elements to establish roles and responsibilities for all communities of practitioners and specialties within the community. For example, IT management and architecture would include specialties such as applications architects and managers and infrastructure architects and managers, as well as IT managers and architects. Insight management and architecture would include specialties such as data and information architects, data and configuration managers, record managers, knowledge managers, and architects. And finally, through this establishment of domain-specific roles and responsibilities, the understanding and communication of EA is improved with value to the enterprise, because additions or changes to any elements of a capability must be managed and controlled to consider the elements of the capability, the other elements of the capability. For example, additions of or changes to the workflow element of the process capability must be managed and controlled to consider effects to policy and effects to procedure. But more importantly, workflow must also be managed and controlled to holistically consider effects on other capabilities and their elements. For example, the offering of system and service solutions. Workflow in the offering of solutions has relationships with and therefore must also holistically consider the process-related elements of business operations. For example, value stream. Workflow has relationships with all elements of insight and with the insight-related and process-related elements of IT information utilization. All of which has relationships with the overarching needs for the integration of capabilities and resources and compliance with requirements and regulations imposed on all elements of the enterprise. In addition, there are second degree of separation functionalities reaching out to, for example, the talent by driving an associated need for training. The details of talent training is related to the details of process roles, which reach back to process, workflow, policy, and procedure, and reach out to enterprise governance and possibly beyond. Which wraps up the presentation. And next, please feel free to contact me. More information can be found on the web. Thank you for attending, and I'll be glad to answer any questions you may have.
Thank you, Mark. I believe you covered a lot of subjects that we've always had trouble in telling our managers all the importance of all these interdependencies. If you would ask a question, get a microphone, and state your name and your organization you're with. Thank you.
Harry Windsor, I'm a retired applied scientist. One of the clear limitations to what you've described, maybe it's just an inadvertent omission, is the difficulty of operating a system when the goal is far enough in the future that the current people being employed in it are gone by the time that the result is to be done. That particular difficulty, best phrased by a politician that said, why should I worry about my grandchildren? After all, what have my grandchildren done for me now? So how does one set these things to enforce a mission when the people are not necessarily seeing the mission affecting their immediate future?
Okay, well, what you have to do is you have to look at the way all of the systems interact with each other. So let me go back here and I'll start with the enterprise capability for you. This enterprise capability, this is the control system. So basically what you're getting out of this is management and control. And the control starts with governance. Organization breaks things up, integration puts them back together. And then compliance and assurance in terms of the final product. But enterprise management over there, that is of those capabilities, but enterprise management reaches down to all the other, attaches to all the other managements. So in the next one, in the business capability, what we have is business management and talent, and there would need to be, from business management, would place talent management on top of talent, so that you would manage your talent to make sure that you would have the right talent, that you would be growing the right talent to be able to take over.
But if something is in the future far enough, you may not know what the talent needs to be educated for until you get results that are still in the future far enough that you can't tell. There's an essential difficulty in the time behavior of the system that you have not addressed.
Yes, that's, I would guess that the way that one would have to work with this is you would have to incrementally go through these same steps over and over again as you have more information, similar to you develop a design.
That's true unless it turns out that you don't get the information to tell you your policies aren't working until it's too late.
Well, yes, that's why it's important to have a reiterative process going on and not just be waiting for some time in the future to say we're going to go do it. It should be a reiterative process that's constantly happening based on what you know of the future at that time. And then you would revisit that over and over again, is the way that I would see it.
As long as you're putting effort into the development of systems or measurement technologies
right.
that can predict far enough in the future but you still won't know about how well they predict into the future until the future comes.
Right.
And that problem of trying to work with lagging indicators versus leading indicators is an essential change of perspective that I don't see you have factored into this graphical organization and evolution.
Right. Yes, you're right. It's not, does not show that.
And yet I feel it's essential in order to get things done, like, for instance, climate management.
The thing that I'm thinking about is that in terms of this definition, where that might fit in better is taking this definition and starting to utilize it. And in the utilization, come up with a process for growing that talent, for growing that ability.
I can see that as something that's possible when you have enough time to use it. Otherwise, you probably have to make some kind of an assumption that may not be popular, or give up entirely and not let that particular goal be achieved until later on you can see a way to do it.
Right.
Either of which seem to me to be rather risky parts of the approach.
Right.
No, thank you. Let me step in for a little bit. I think maybe that would be a good application of some of the agile technologies processes where you're trying to figure out as you go along what capabilities you need, not only in personnel, but also in system capabilities. We got another question here.
Paul Martin, SE Scholar. Hey, I was just wondering, I like the way you present all the capabilities that a business would come up with. And I was wondering if you looked at the way Amazon tried to work their capabilities. They always made a capabilities as a service model.
Okay.
Yeah, yeah, you should look into it. Their Amazon Web Service grew out of their need for their IT structure to work within their web ordering system. And they said, look, we got this capability, why don't we sell it? And so they actually sell that capability to others to use and go on top. And then they're starting to do it with other capabilities they have in their business and in their organization. And what it forces them to do, and I just read an article, and that's why I'm a little excited about it, but what it forces them to do is not just have their internal customers. They have external customers too. And because of that, the external customers expect certain expectations versus the internal. And it forces them into this always keeping up, you know, and always changing and always looking at the way to run things.
Right.
Absolutely amazing method to take this and just kind of turn it into this bizarre business thing where Amazon's taking over the world, basically. Especially when you start looking at the way they ship things and things like that. People don't want to do it anymore, so they're having Amazon do it. So they pretty much took everything. So I thought maybe you might have some insight into that and talk to it.
No, I didn't, but I think I'll look into it.
Sorry, didn't mean to add to this. But
I did use a little bit of Amazon.
Yeah. Look into it. Okay, thanks.
Yes.
Dave Abley, ITC. I know in enterprise architecture, a lot of times you mentioned you work with some very small startups up to the big mega corporations with this, right? So I know from my experience, a lot of times there's a lot of not clarity when people do enterprise architecture, why they're doing it, and it becomes shelfware. And a lot of this stuff I've seen anyway. So I was curious, when you go from how would a startup view this? What would they use? What would you tailor for them versus the larger ones? Because if you as you mentioned, the domain, the environment you're in, this stuff can very easily become shelfware, unusable, and EA gets a bad name.
Right, well, this is really just a starting point for for them to build their specific architecture around. So what it does is it basically sets the first two levels of the architecture as a standard, being the six basic and fundamentals, and then each one has six inside of it. So if we took, for instance, IT and IT applications. Within IT applications, you would start to structure all the different applications that one would have in the business. So when you would start on a company would start out, the definition would be small, right? They would probably have information technology. They may not need to describe it any further than that. Certainly, a sole proprietor or somebody like that, they have all these same needs, but the degree to which it's matured and the way that they handle it is different, right? I'm an independent management consultant. I have financial management responsibilities in my company. They're not as great as the financial management responsibilities in a company like Amazon, but nonetheless, I have it. So, but it's small for me. A lot of stuff I can maybe keep in my head. I don't really need to document an architecture. I can work with it organically to a certain point in time. But as the business grows and its needs become more complex, that's when they have to actually start documenting. So what this does is it starts out very simple and it just lets them grow to bigger and bigger substructures underneath the two main structures. That answer your question?
It's terrible and scalable.
Yeah.
Steve Sutton, retired systems engineer. What my suggestion would be that that it might help to describe this in terms of some case studies. Amazon might be an example. Sole proprietorship may be an example. U.S. government might be an example, or a department within the government, to show how all these things are interconnected in a realistic.
Right.
I think that would be helpful.
Another presentation.
Yeah, better visualize and associate your abstractions with realities that become possible.
Thanks.
We still got a few minutes. All right, well, we'll wrap it up now. We have to give up the book. So, actually, a signed copy by the author. Let me. And it's first edition too, so it might be valuable in these days.
225687.